Welcome back to The Hidden Layer, the channel where we decode the AI that's literally reshaping our world. Today, we are sinking our teeth into a problem that every single AI engineer is facing. How do you build agents that you can actually truly trust? We're going to break down an amazing paper from Microsoft Research and show you exactly how to apply its insights in your own work. So, our guide for today's deep dive is the Art of Building Verifiers for Computer Use Agents. And trust me, this paper tackles one of the biggest, most frustrating bottlenecks in AI right now.
All right, let's just jump right into it. Picture this. You give your shiny new AI agent a task. It chugs along for a few minutes and then comes back with that beautiful little message, success. But how do you really know? How can you be sure it didn't just fail quietly or even worse, completely make up a result?
Take a look at this. This is a real example. An agent was asked to pull some performance numbers from a paper. It came back and said, hey, I found a plus 6.2% improvement. Sounds great, right? Except the actual text, which the agent was looking directly at, said plus 2.8%. That is not a simple mistake. It's a flat-out fabrication, a silent failure that could completely poison your entire project. And that is the exact problem we're going to solve today. In the next 5 minutes, I'm going to walk you through 4 essential principles from this paper for building verifiers that can catch these sneaky errors. And hey, make sure you stick around to the end because we are going to reveal the one crucial skill that still separates a top-tier human researcher from an AI, and I promise, it's not what you think. So here's our game plan. First, we'll unpack this whole AI trust problem and see why so many verifiers just fall flat. Then we'll introduce Microsoft's really elegant solution and its 4 core principles. And we'll wrap it all up with a practical blueprint you can actually use, and a really fascinating look at human versus AI intuition. You know, the heart of this issue is really what you could call the illusion of success. Our AI agents are getting so good at looking like they're doing complex stuff on a computer, but what's happening under the hood? Well, that can be a totally different story.
So why is this so stinking hard? Well, think about it. Unlike just generating text, these tasks are long, they involve dozens of steps, tons of screenshots, and the very idea of success can be kind of fuzzy. And like we saw, a failure can be one tiny detail buried in step 47 of a 60-step process. The stakes here are absolutely massive, because if your verifier gets it wrong, you're not just getting a bad result, you're poisoning your benchmarks and all of your future training data.
Now, let's really get a feel for how badly things can go off the rails. The scale of this problem might actually shock you. Get a load of this number. This is the false positive rate for a pretty standard web browsing agent verifier. Yes, you're reading that right. It means that when the AI said it succeeded, it was actually wrong almost half the time. A system that's wrong half the time isn't just unreliable. It's actively making things worse. So to fix this mess, the researchers at Microsoft didn't just throw another model at the problem. No, they went on this whole journey, running tons of experiments to figure out what really works. And the result is this awesome system they call the Universal Verifier. And the Universal Verifier is built on 4 core design principles. This is the absolute heart of today's explainer, so let's break them down one by one. Okay. Principle number 1 is all about building on a solid foundation, and that foundation is your evaluation rubric. The researchers found that LLMs often cook up these messy rubrics with phantom criteria the user never even asked for, or criteria that overlap. This causes one tiny mistake to snowball into a huge penalty. So the key takeaway is this. Your rubric must have specific, independent criteria that are tied only to what the user actually wanted. Principle 2 is a game changer. Separate the process from the outcome. This means you're asking 2 totally different questions. First, did the agent follow the right steps? That's your process reward. It gives credit for best effort. But second, was the user's goal actually achieved? That's the outcome reward. So an agent might do everything perfectly but get stopped by a CAPTCHA. It deserves a high process score, for sure, but the outcome is still a failure. This separation gives you a way richer, more nuanced signal for what's really going on. The third principle is really all about fairness. You have to distinguish between things the agent can control and things it can't. You know, if a product is out of stock or a website is down, the agent shouldn't get punished for that. By flagging these uncontrollable factors, your scoring becomes way more accurate, and it actually reflects what the agent was truly responsible for. And the final principle is about managing the evidence. In a long task with, say, 100 screenshots, how in the world do you find that one frame that shows a critical failure? You can't just check the last one. So the Universal Verifier uses this brilliant divide and conquer strategy.
It creates a relevance matrix, scoring every single screenshot against every single criterion in the rubric. This makes sure that the most critical pieces of visual evidence are always found, no matter where they're hiding in the timeline.
Okay, so you've got the principles. That's great. But how do you, as an engineer, actually put them to work? Let's turn all this research into a super practical blueprint. You can really think about your whole verification pipeline in these 5 steps. 1. Generate a clean, specific rubric based only on the user's goal. 2. Use that relevance matrix idea to find the key screenshots for each goal. 3. Analyze that visual evidence to see if it backs up or contradicts what the agent claims. 4. Do a completely separate pass just to check for any weird, unintended side effects. And 5. Judge the final outcome. Following this blueprint brings all these powerful principles right into your daily workflow. Now, for that question I left you with at the start, the researchers didn't just build this system. They also tested if an AI could have come up with it on its own. And this is where we see the really unique, almost irreplaceable value of human intuition. Just look at this graph. That red line is an auto-researcher AI trying to design the verifier from scratch. And man, it was fast. It got to 70% of the human expert's quality in just 5% of the time. But its improvements were all tiny incremental tweaks. Now look at the blue line. That's the human expert. See those massive jumps? Those were the big aha moments, the conceptual breakthroughs, like realizing they had to separate process from outcome. The AI was amazing at optimizing, but it was the human who drove the real innovation. And this leads us to what I think is the core takeaway of the whole paper, summed up perfectly in this quote. Building these systems isn't just about code and algorithms. It's an art. It's about taking that fuzzy human concept of success and figuring out how to translate it into a system that a machine can understand and follow, time and time again. So, we'll leave you with this question to chew on. We're all obsessed with making AI agents more and more capable, but maybe the real question we should be asking is this. As AI gets better at doing things, how do we get better at trusting the results? The principles we talked about today are a massive step in the right direction. Thanks so much for watching.